There is a lake in northern Manitoba that doesn't appear on tourist maps. It has a name, but I won't share it here. Not because the information is classified, not because I'm protecting some grand conspiracy, but because the lake deserves to remain what it has always been. Unremarkable, ignored, ordinary. People fish there. Locals have been pulling pickerel and northern pike from its waters for 3 generations. There are 7 cabins along the western shore, built in the 1950s when lumber was cheap and land was cheaper. In summer, families arrive in pickup trucks loaded with coolers and fishing rods. Children swim in water so clear you can see 15 feet down to the rocky bottom. In winter, ice fishermen drill holes through 3 feet of ice and sit in heated shacks, drinking coffee from thermoses, waiting for something to bite. Nothing remarkable has ever happened there. No drownings, no accidents, no mysterious disappearances. The lake has never frozen early or thawed late. Its fish populations remain stable. Its water quality is excellent. Property values around it are modest but consistent. Insurance companies don't flag it. Environmental agencies don't monitor it. It is, by every measurable standard, boring. That is the point. That's why it was chosen. The lake sits in a depression carved by glaciers 10,000 years ago. The surrounding terrain is classic Canadian shield, granite bedrock covered by thin soil supporting dense pine and spruce forest. The watershed is small and undeveloped. No agriculture, no industry. The nearest town is 40 minutes away by gravel road. Population 300 give or take. In spring, the ice breaks up around mid-April. Meltwater fills the lake from streams that dry up by June. In summer, water temperatures reach the mid-60s at the surface, while the depths remain cold. In fall, the lake turns over as surface water cools and sinks, mixing the layers. In winter, ice forms in late November and doesn't break until April returns. Year after year, decade after decade, century after century, nothing changes, nothing remarkable, nothing to draw attention. That's the beauty of it. That's why it was perfect. Chapter 1. The research assignment. My name is irrelevant to this account. What matters is my credentials and why I was there. I hold a master's degree in freshwater microbiology from the University of Manitoba. My undergraduate work focused on extremophiles, organisms that thrive in environments hostile to most life. I study bacteria in acidic hot springs, where the pH would dissolve human flesh. I catalogued algae in Arctic lakes that spent 10 months a year under ice. I documented microbes living in geothermal vents where temperatures exceeded the boiling point of water. I was trained to find life in impossible places, but in late April, my supervisor assigned me a project that seemed, at first, like punishment for some unknown offence. I need baseline data on an unstudied lake system, she said, sliding a manila folder across her desk. Inside were topographical maps, satellite imagery, and water quality reports from the provincial government. Nothing fancy, just standard microbial surveys, species diversity, population density, seasonal variation, basic ecology. I flipped through the documents. The lake looked ordinary, small, remote, unremarkable. Why this lake, I asked. Because it's never been formally studied. It's clean, stable, no pollution sources, no industrial activity within 50 kilometres, no agricultural runoff. It's perfect as a control environment for future comparative studies. Control for what? Future studies. We need pristine baseline data to compare against systems that are experiencing environmental stress, climate change, pollution, development. We need to know what normal looks like before we can measure deviation from normal. It made sense. In science, you can't measure change without first establishing what healthy baseline conditions look like. You need controls, reference sites, places that haven't been touched by human activity beyond the most minimal interaction. How long, I asked. 6 weeks, maybe 8 if you find anything interesting. Take weekly samples, run the standard analyses, document everything. Write it up. Should be straightforward. I looked at the maps again. The lake was 3 hours north of Winnipeg. Middle of nowhere. No cell service. The nearest town was 40 minutes away, population under 500. There's a cabin you can use, she added. Belongs to a friend of the department. Hasn't been occupied in a few years but should be functional. Generator, propane stove, outhouse. Outhouse. It builds character. Besides, you're a field researcher. You've worked in worse conditions. She wasn't wrong. I had spent 3 weeks in the Arctic, sleeping in a tent on permafrost. I had worked in swamps thick with mosquitoes and leeches. An outhouse was luxury compared to digging cat holes in frozen tundra. I took the assignment because I had no choice. Graduate students don't refuse field work. Besides, part of me welcomed the isolation. My personal life had been complicated lately. A relationship that had dissolved slowly and painfully over the previous year. Friends who had gradually drifted away as graduate school consumed all my time. Parents who called less frequently. Disappointed that I had chosen research over medical school. The idea of 6 weeks alone in the wilderness, with nothing but science to focus on, felt like a reprieve, an escape, a reset button. I spent 3 days preparing. I packed my equipment methodically, checking and rechecking everything. Sample containers in 3 sizes, sterilised and sealed in plastic bags. A portable microscope that had cost me 2 months' stipend but was worth every penny. A pH meter calibrated to 3 decimal places. A temperature probe accurate to 0.1 degrees Celsius. A dissolved oxygen sensor that could measure down to parts per million. A conductivity meter for testing water salinity and ion content. A handheld spectrophotometer for analysing light absorption at different wavelengths. Filters and pumps for processing large water volumes. Preservatives for fixing specimens. Notebooks with waterproof pages. A laptop loaded with analytical software. 2 backup hard drives for redundancy because data loss is a researcher's worst nightmare. Then the personal supplies. Enough non-perishable food to survive a nuclear winter. Canned soups, dried pasta, rice, beans, oatmeal, protein bars, instant coffee, powdered milk, peanut butter, crackers, trail mix. A first aid kit extensive enough to handle everything short of major surgery. Ibuprofen by the bottle, batteries for every device, LED lanterns and headlamps, a satellite phone for emergencies, books for the long evenings, mostly paperback science fiction, and a few scientific journals I'd been meaning to read. A journal I told myself I would actually write in this time, though I never did. I loaded everything into my decade-old Toyota, which groaned under the weight but started reliably. That car had taken me through 4 years of fieldwork across Manitoba and Saskatchewan. It had gotten stuck in mud and been pulled out by tractors. It had forded rivers that were deeper than recommended. It had once caught briefly on fire from an electrical short, but I had managed to put it out with a fire extinguisher. But it always got me where I needed to go, which was more than could be said for most vehicles at that price point. The drive north was long and progressively more isolated. Highway turned to provincial road. Provincial road turned to gravel. Gravel turned to a rough 2-track path through dense pine forest that scraped the sides of my car. I drove for 3 hours, watching the landscape change from farmland to forest, from populated to empty, from cell signal to nothing. I arrived on a Thursday morning in late April. Spring thaw had come early that year. The ice had broken up 2 weeks prior, leaving the lake open and glassy under overcast skies that promised rain. The temperature was cool but not cold, maybe 10 degrees Celsius. The wind carried the smell of wet earth and pine needles, that distinctive scent of northern spring that combines decomposition and renewal in equal measure. A small aluminum boat waited at a weathered dock, chained to a post that leaned at a concerning angle. The boat had clearly seen better decades. Its paint was flaking off in sheets. The oars were cracked and splintered. One seat had partially rotted through, but the hull looked watertight, which was all that mattered. I could make do with a terrible boat as long as it floated. The cabin stood about 50 yards from shore, nestled among pines. 1 room, maybe 12 feet by 12 feet. Wood stove that looked like it dated to the 1970s, all cast iron and rust. A camp cot with a sleeping bag that smelled of mildew and mouse nests. A table made from rough-cut lumber, and one chair that didn't quite match. Shelves with mouse droppings and the remains of someone's forgotten canned goods from years past. Labels faded beyond recognition. The windows were clouded with age and grime. The door hung slightly crooked on its hinges, leaving a gap that would let in cold air and insects. The walls were uninsulated bare wood, covered in graffiti from past occupants, names and dates going back decades. Tom and Linda, summer 78. The Johnson family was here, 1982. This place is haunted. Leave while you can, seriously, not joking. That last one made me smile. Every isolated cabin is supposedly haunted. It's a universal constant. The outhouse stood about 20 yards from the cabin, leaning slightly to the left like a drunk trying to appear sober. Its door hung crooked on rust-coated hinges that squeaked when I pulled it open. Inside was exactly what you'd expect. A wooden seat worn smooth by use and weather. Spiders in the corners. A roll of toilet paper in a plastic bag to protect it from moisture. A hook for a lantern. Graffiti here too. Someone had carved, "Abandon all hope ye who enter here" into the wall. Appropriate. Someone else had written, "Aim carefully, the next person might be you." Practical advice. I unloaded my gear in 3 trips from the car to the cabin. The afternoon was wearing on. The sky had darkened with approaching weather. I could smell rain in the air, that particular petrichor scent that precedes storms. I spent the next 2 hours setting up my workspace, creating order from chaos. I organised my equipment on the cabin's single table, which I first had to scrub clean of years of accumulated dirt, dust and cobwebs. I tested the generator, which sputtered and coughed like an old man with emphysema before finally roaring to life, producing enough power to run my equipment and charge my devices. I filled water jugs from the lake, boiled them on the propane stove and let them cool. Basic field protocol. Never trust water sources even in remote areas. Giardia and other parasites don't care how pristine a lake looks. By evening, I was exhausted and covered in dirt and sweat. The rain started just as darkness fell, heavy drops that drummed against the metal roof with surprising violence. I heated a can of chicken noodle soup directly on the propane stove, ate it straight from the pot while standing at the window, watching lightning flash over the lake. The storm was beautiful and violent. Thunder rolled through the valley like artillery. Wind bent the pines almost horizontal. The lake's surface erupted with raindrops, turning smooth glass into chaos. I washed my face and hands in cold water, changed into clean clothes and lay down on the camp cot. That night, I slept better than I had in months, maybe years. No traffic noise, no neighbours arguing through thin apartment walls, no sirens wailing past at 3 a.m, no helicopter spotlights scanning for criminals, no light pollution turning the night sky orange. Just darkness and silence and the occasional call of a loon from somewhere across the water. That haunting sound that might be the loneliest noise in nature, beautiful and melancholy in equal measure. I woke before dawn. The storm had passed. The air smelled clean and fresh. I made instant coffee that tasted like burnt rubber, but contained caffeine, which was all that mattered, and prepared for my first sampling run. Standard field work. Nothing complicated. Basic procedures I had performed hundreds of times during my undergraduate and graduate work. I dressed in waterproof waders that came up to my chest, grabbed my collection kit and headed to the dock. The morning was absolutely still. Morning mist clung to the lake's surface like a living thing, shifting and curling in imperceptible currents. I could see my breath. The sky was pale grey, the sun not yet visible but approaching from the east, painting the clouds in shades of pink and orange. Birds were beginning their dawn chorus. A beaver slapped its tail somewhere in the distance, the sound carrying across the water like a gunshot. I untied the aluminum boat and pushed off. The oars creaked in their locks as I rowed. Each stroke sent ripples spreading out in perfect circles that disrupted the mirror-smooth surface. The water was so clear I could see down 15 feet to the rocky bottom near shore, where minnows darted between stones and aquatic plants swayed in invisible currents. I had planned my sampling locations carefully using topographical maps and GPS coordinates. 3 sites representing different habitats and depths. Site 1, near shore in shallow water, 5 feet deep, where sunlight penetrated all the way to the bottom. This was the warm, productive zone where photosynthesis occurred and most aquatic life concentrated. Site 2, mid-lake at moderate depth, 30 feet down, in the zone where light began to fade and temperature started to drop. Site 3, directly above the deepest point, which the maps indicated was roughly 80 feet down, in the dark, cold water where few things lived. At each location, I deployed my collection equipment with practiced efficiency. I used a Van Dorn bottle, a cylindrical device that collects water from specific depths without contamination from other layers. You lower it open, then trigger it remotely to snap shut, trapping water from exactly the depth you want. I measured temperature with a probe that I lowered slowly, watching the digital readout change as it moved from warm surface water into progressively colder depths. I tested pH with both electronic sensors and chemical indicators as a backup, because electronics fail and chemistry doesn't lie. I measured dissolved oxygen using the Winkler method, a complex procedure involving chemical reactions that turn water pink or clear depending on oxygen content. I collected plankton samples with a fine mesh net that I towed behind the boat, filtering thousands of gallons to concentrate the microscopic organisms. Water temperature was consistent across all 3 sites at the surface, 6 degrees Celsius, just above the threshold where water reaches its maximum density. Cold enough that I could feel it through my waterproof gloves. The water was starting to stratify as spring warming created layers, but the process was just beginning. Soon there would be 3 distinct zones: warm surface water heated by the sun, a narrow thermocline where temperature dropped rapidly with depth, and cold, dense water at the bottom that would remain near freezing all summer. Oxygen levels were normal, 8 parts per million, plenty to support fish and other aquatic life. Some lakes suffer from hypoxia, especially those with heavy algae blooms that consume oxygen as they decompose. This lake was well oxygenated, healthy. Visibility was excellent, measuring over 12 feet with a Secchi disc, a simple tool that's been used for over a century. You lower a black and white disc into water and note the depth where it disappears. More than 12 feet means the water is very clear. Less than 6 feet suggests turbidity from algae or suspended particles. The water was slightly alkaline, pH 7.8, which was perfect for most freshwater species. Too acidic and many organisms can't survive. Too alkaline and you get similar problems. 7.8 is right in the sweet spot. Everything was exactly as you'd expect for a healthy northern lake in early spring. I returned to the cabin with my samples carefully stored in coolers, each bottle labelled with location, depth, time, and date using waterproof markers. Field protocol is everything. One mislabelled sample can ruin an entire data set. I had seen colleagues lose months of work because they couldn't remember which bottle came from which site. I transferred some water into sterilised containers for microbiological analysis. I preserved other samples with fixatives like formaldehyde or glutaraldehyde that would kill the organisms but prevent decay, allowing me to analyse them weeks or months later if needed. I prepared slides for immediate microscopic observation, using sterile pipettes to place tiny drops of water on glass slides, then covering them with thin cover slips to create a sealed environment for viewing. Under magnification at 400 times, the microbial populations appeared exactly as I expected. Diatoms with their intricate glass shells that looked like tiny jewel boxes, each species with a distinct pattern. Some were circular, others elongated like boats or cigars. Some looked like stars or chains. Their shells were made of silica, essentially glass, and they refracted light beautifully. They were some of the most abundant organisms on Earth, producing oxygen through photosynthesis and forming the base of aquatic food webs. Cyanobacteria in long filamentous chains that looked like microscopic strings of beads. These ancient organisms had been producing oxygen on Earth for billions of years, long before any animals existed. They were the reason our atmosphere became oxygen-rich. They were still everywhere, in every body of water, doing the same job they had done for eons. Protozoa gliding through the water with their hair-like cilia, beating in coordinated waves, creating currents that pulled food particles toward their mouths. These single-celled predators hunted bacteria and smaller organisms, using their cilia like oars to propel themselves and manipulate their environment. Rotifers spinning in place, their feeding structures creating tiny whirlpools that were fascinating to watch. They looked like tiny transparent wheels rotating rapidly, hence their name. They fed on smaller organisms by creating water currents that pulled food into their mouths. There were copepods, tiny crustaceans barely visible to the naked eye, with segmented bodies and feathery antennae they used to sense their environment. There were algae of various species, green and brown and sometimes red, each species adapted to different light conditions and nutrient levels. Everything you would expect in a healthy northern temperate lake in early spring. But their behaviour was unusual. They moved in coordinated patterns. At first I thought it was an optical illusion caused by water currents on the slide creating flow patterns. But no, this was different. I was seeing actual coordination between organisms, not random drift, not the instinctive schooling behaviour of zooplankton responding to predators or following chemical gradients toward food sources. This was structured movement, deliberate, organised. I watched through the microscope as thousands of diatoms moved in formation. They maintained consistent spacing like dancers or marchers in a parade. They changed direction simultaneously, all turning at the same moment as if responding to the same signal. They formed patterns that reminded me of flocking birds, those murmurations of starlings that twist and turn through the sky, as if controlled by a single mind. But birds have nervous systems. Birds have eyes and brains and can see each other and respond to visual cues. Diatoms are single-celled organisms with no nervous tissue whatsoever. They have no eyes, no brain, no ability to see their neighbours. They shouldn't be capable of group coordination. Yet here it was. Cyanobacteria chains aligned themselves parallel to one another, all pointing in the same direction like compass needles finding north. Protozoa maintained precise spacing, as if there were invisible barriers between them, maintaining distances that appeared mathematically regular. When one moved, others nearby adjusted their positions to maintain the spacing, like dancers maintaining formation even as the formation moves across a stage. I watched for an hour, making detailed notes and taking photographs through the microscope's eyepiece using my phone camera. The patterns were real, consistent, repeatable. I could see them in sample after sample, in water from different depths and different locations. This was not random. This was not an artifact. This was real behaviour. I assumed contamination. Perhaps my collection bottles weren't as clean as I thought. Perhaps I had introduced some chemical during collection that was affecting behaviour, like a detergent or preservative that was altering how organisms moved. Perhaps there was something in the cabin's water supply I used for washing equipment, some mineral or compound that was changing the water chemistry in subtle ways. Laboratory contamination is one of the most common sources of error in microbiological research. It's embarrassingly easy to contaminate samples. A fingerprint, a breath, a speck of dust. Anything can introduce foreign substances that alter results. Good researchers are paranoid about contamination. I prepared fresh samples using equipment I sterilised with alcohol and flamed with a butane torch until the metal glowed red. I used distilled water I had brought from the university specifically to avoid any possibility of chemical contamination from local water sources. I prepared slides in triplicate to rule out random variation. I used different microscope objectives to eliminate the possibility of optical artifacts. Same result. The organisms were coordinating. I spent the next 6 hours rechecking everything. I sterilized all my equipment with both alcohol and heat. I used distilled water controls to verify my microscope wasn't somehow malfunctioning, showing patterns that weren't actually there. I examined blank slides with nothing on them to make sure I wasn't seeing artifacts in the glass itself. I tested samples from different depths and different locations around the lake, rowing back out 3 more times to collect samples from sites I hadn't visited yet. Every sample showed the same phenomenon: coordination. This shouldn't be possible. Microorganisms don't coordinate. They respond to chemical gradients, following invisible trails toward food sources like nutrients or away from toxins. They follow pheromone trails left by others of their species, chemical messages that say food here or danger there. They react to light through simple photoreceptor proteins, swimming toward or away from brightness depending on whether they need light for photosynthesis or want to avoid UV damage. They sense temperature and seek their optimal thermal range, moving up or down in the water column to find comfortable conditions. But they don't organize into formations. They don't maintain geometric spacing. They don't move as a collective with coordinated timing. These did. By midnight, I was exhausted and deeply confused. My eyes ached from staring through the microscope for 14 hours straight. My back hurt from hunching over the lab table. My hands were stiff from pipetting and writing notes. I had filled 3 notebooks with observations and diagrams. I had taken hundreds of photographs. I had video recordings showing the coordination in real time, proof that I wasn't imagining things. The data was undeniable. Something unusual was happening in this lake. Something I had never seen before. Something that violated my understanding of how microorganisms behave. I filed a preliminary report on my laptop, carefully choosing my words. Unusual motility patterns observed in multiple microbial species from all sample depths and locations. Possible coordinated behavior between individuals requires further investigation. Contamination ruled out through multiple sterilization protocols and control procedures, seeking guidance on appropriate methodology for documenting and analyzing observed phenomena. I attached several video files showing the patterns clearly. I included still photographs with annotations. I provided detailed notes on my collection and analysis methods. I sent the report via satellite internet, which took 45 minutes to upload given the terrible connection speed available in the wilderness. The progress bar crept forward at a glacial pace, while I made tea and paced the cabin. Then I went to bed, lying on the camp cot with my mind racing. Sleep was impossible at first. I kept seeing those formations in my mind, diatoms moving like flocking birds, bacteria aligning like iron filings around a magnet, protozoa maintaining mathematical spacing like soldiers in formation. What was causing it? Chemical signals I couldn't detect with my equipment? Electrical fields generated by the organisms themselves? Magnetic orientation using Earth's magnetic field? Something in the water I hadn't tested for? Some compound or element that was coordinating their behavior? Or was I simply observing a natural phenomenon that had somehow gone undocumented in over 1.5 centuries of microbiology research? That seemed impossible. Microbiologists had been studying freshwater systems since the invention of the microscope. Millions of observations, thousands of papers, entire journals devoted to the topic. Someone would have noticed coordinated behavior if it was a normal thing that happened. Unless it wasn't normal. Unless this lake was different somehow. But why? What made this lake special? The geology was unremarkable. The chemistry was normal. The location was ordinary. There was nothing about it that should produce unusual biology. I finally fell asleep around 3 a.m, my dreams filled with geometric patterns and moving shapes. When I woke at dawn, my first thought was that maybe I had made a mistake. Maybe I had been so tired that I had misinterpreted what I was seeing. Maybe in the clear light of morning, everything would look normal. I dressed quickly, made coffee, and immediately prepared new slides from yesterday's preserved samples. The coordination was still there. If anything, it was more pronounced. The organisms had somehow continued organizing even after preservation, which should have been impossible. Formaldehyde kills microorganisms instantly. Dead things don't move. Dead things don't coordinate. Yet the patterns in yesterday's samples had become more defined overnight. The spacing between organisms was more regular. The alignments were more precise. I stood there staring at the microscope, coffee growing cold in my hand, trying to make sense of what I was seeing. This was not normal biology. This was something else, something I didn't have a framework to understand. I returned to the lake. The water was perfectly still. Morning fog clung to the surface like a blanket. I took new samples from the exact same coordinates as the previous day, using the GPS unit to ensure precision within a meter. I wanted to see if the coordination was consistent across time, if whatever phenomenon I was observing was stable or transient. This time, the organisms behaved differently, not just in movement, in structure. They had changed. Under magnification, I could see that multiple species had altered their morphology. Diatom shells that had been smooth yesterday now had small projections like spines or ridges. Cyanobacteria that had been simple filaments now showed nodular thickenings along their length, like beads on a string. Protozoa had developed additional cilia, giving them more mobility and control. This was impossible. Evolutionary adaptation occurs over generations through mutations and selection. A single organism doesn't change shape during its lifetime except through growth. Phenotypic plasticity, the ability of individual organisms to change in response to environmental conditions, takes weeks or months at minimum, not overnight, not in less than 24 hours. I checked my notes 3 times. I reviewed yesterday's photographic records and compared them side by side with today's samples using split-screen software. I measured cellular structures with micrometer precision using the microscope's digital measuring tools. The changes were real. Shell structures were denser by an average of 12%. Flagella were longer by 15 to 20%. Cellular walls had thickened by 10 to 18% depending on species. These weren't different organisms. These were the same species I had observed yesterday, but they had changed. They had adapted. They had modified their physical structure overnight. And then I noticed something else that made my hands shake as I adjusted the microscope's focus. The microorganisms were moving toward the center of the slide, not randomly, not following nutrient gradients or light or temperature gradients created by uneven illumination. They were gathering deliberately, forming clusters, creating structures that served no obvious biological function. I watched for 2 hours as billions of microscopic organisms self-assembled into geometric patterns on the glass slide. They built something that looked like a honeycomb, hexagonal cells arranged in a perfect pattern. Then they dissolved the structure and formed a spiral, like a nautilus shell or a galaxy. The spiral became a grid, perfectly square cells arranged in rows and columns. The grid became concentric circles, like a target or tree rings. They built a lattice, a 3-dimensional structure that extended through the depth of the water droplet. I need to be absolutely clear about what I observed because it sounds insane. This was not biofilm formation. I know what biofilms look like. I had studied them extensively during my undergraduate work. They're chaotic, adhesive mats created by bacterial colonies secreting sticky polymers that hold them together. Biofilms are messy and irregular, growing in whatever direction nutrients are available. This was architecture, deliberate, precise, repeating patterns that exhibited mathematical regularity. Fractal geometry, where each small section resembled the larger whole. Each structure was symmetrical. Each formation maintained exact spacing between organisms. I photographed everything with both my phone and my microscope's built-in camera. I took videos showing the structures forming in real time, organisms moving into position like construction workers building a skyscraper. I collected specimens and preserved them in fixative to prove I wasn't hallucinating or experiencing some kind of equipment malfunction. The evidence was overwhelming. Something was very wrong, or very right in a way that shouldn't be possible. I spent the rest of the day documenting everything. I filled 2 more notebooks with observations. I collected samples from a dozen locations around the lake. I tested different depths. I tried different collection methods. I varied the time of day. Every sample showed the same thing: coordination, adaptation, structure formation. Whatever was happening throughout the entire lake, not just in one isolated area, not just at one particular depth, everywhere. This was a lake-wide phenomenon. I sent another message to my supervisor. Need to discuss findings immediately. Something highly unusual in samples. Multiple species showing coordinated behavior and rapid morphological changes. This is not contamination. This is not equipment malfunction. Something genuinely anomalous is occurring. Please call. She called within an hour. I could hear the tension in her voice. What's going on? She asked. Your message worried me. I explained everything in detail. The coordinated movement I had observed, the overnight morphological changes, the geometric structures, the fact that it was happening in samples from all locations and depths. Is your equipment malfunctioning? She asked. I've triple-checked everything. Different microscopes, different samples, different collection methods, multiple controls. The phenomenon is real. Then you're looking at contamination from some source you haven't identified. From what source? I'm in the middle of nowhere. I'm using sterilized equipment. I'm following every protocol we use in the university labs. I've run every control I can think of. This is not contamination. Silence on the line. I could hear her breathing. I could imagine her sitting at her desk, staring at her computer screen, trying to process what I was telling her. Send me everything, she finally said. Photos, videos, detailed notes, protocols, everything you've done. I need to see exactly what you're seeing. I already sent the preliminary report. Send more. Send everything, every observation, every measurement, every photograph, and don't discuss this with anyone else, not colleagues, not friends, no one. Why the secrecy? Because if this is what you think it is, if this is genuinely novel biology, premature disclosure could be problematic. People will assume contamination first. They'll assume you're incompetent or delusional. We need ironclad evidence before we even think about publishing. And if you're wrong, if there is a mundane explanation you've missed, we need to find it before you damage your reputation. You think I made a mistake? I think you're a careful researcher and something unusual is happening. That's all I can say right now. I'm sending someone to verify your observations, someone with extensive field experience. He'll bring his own equipment and run independent tests. If he sees what you're seeing, then we know it's real. If he doesn't, we know there's something wrong with your methodology or equipment. Who are you sending? Marcus Holt, senior field researcher. He specializes in unusual aquatic systems. If anyone can figure out what's happening, it's him. How soon? He's leaving tomorrow. He'll be there in 3 days. I stood there in the cabin, phone pressed to my ear, feeling a strange mixture of vindication and anxiety. Vindication because my supervisor was taking me seriously enough to send someone. Anxiety because what if Marcus couldn't replicate my observations? What if whatever was happening stopped before he arrived? What if I really had made some terrible mistake that I couldn't see? Stay on site, she said. Keep sampling. Document everything. Don't change your procedures. We need consistency. And seriously, don't talk to anyone about this. Not until we understand what we're looking at. She hung up. I stood there staring at my phone, then at the microscope, then at the window showing the lake beyond. Something was wrong with that lake, or something was right with it in a way that violated everything I understood about biology. For the next 3 days, I barely slept. I collected samples every 6 hours around the clock. Dawn, noon, dusk, midnight. I documented everything obsessively. Every pattern, every structure, every change. The coordination continued. The adaptations continued. The structures became more complex. And I began to notice something else. The lake was responding to my presence. When I approached the shore, microbial activity increased measurably. When I took samples, organisms in nearby water showed heightened coordination. When I left, activity decreased. It was as if the lake knew I was there, as if it was reacting to observation. That thought kept me awake at night. The implications were disturbing. Biology doesn't work that way. Organisms don't respond to being observed unless the observation itself introduces some environmental change like light or heat or mechanical disturbance. But I was being careful. I was minimizing disturbance. I was using gentle collection methods. The organisms shouldn't know they were being watched, yet they behaved as if they did. By the time Marcus arrived, I was exhausted and questioning my sanity. I heard his truck before I saw it, the engine noise growing louder as he navigated the rough two-track path through the pines. When he emerged from the forest, I saw a man in his 50s, tall and lean, with greying hair pulled back in a ponytail that reached halfway down his back. He wore field clothes that had seen serious use, cargo pants with reinforced knees and multiple pockets, a sun-faded Columbia fishing shirt, boots that had been resoled at least once and were held together with duct tape in places. He looked like someone who had spent decades in the field, someone who had seen things, someone who wouldn't be easily impressed or easily fooled. He introduced himself as Marcus Holt, shaking my hand with a grip that was firm but not aggressive. "I'm a senior field researcher," he said. "I specialise in aquatic systems, unusual aquatic systems specifically. I've worked on everything from deep-sea vents to Antarctic ice lakes. Your supervisor showed me your reports. I've been studying freshwater ecology for 23 years, and I've never seen anything like what you documented." "Do you think I made a mistake?" I asked. "I think you're either the victim of the most elaborate contamination event in the history of microbiology, or you've discovered something genuinely anomalous. I'm here to figure out which." He brought his own equipment, a full portable lab worth of gear loaded in boxes and cases, microscopes, spectrometers, centrifuges, genetic sequencing equipment that cost more than my car, pH meters, temperature probes, oxygen sensors. Everything was top-tier professional equipment, the kind you see in well-funded research institutions. We didn't speak much during the first day. He wanted to run his own tests without any influence from my observations or expectations. Blind replication is the gold standard in science. If he saw the same things I saw without knowing what to look for, that would validate my observations. He took his own samples using his own sterile equipment from locations he chose himself. He prepared his own slides. He ran his own analyses using his own protocols. I stayed in the cabin and tried not to hover. I made coffee. I paced. I read the same page of a book 10 times without retaining a single word. I waited. That evening, as the sun set behind the pines and painted the sky in shades of orange and purple, he sat across from me at the small wooden table. "Your data is correct," he said simply. "I know. This shouldn't be possible. I know." He leaned back in his chair, which creaked under his weight. He looked tired. His eyes had that particular exhausted look that comes from seeing something that challenges your entire worldview. "We need to run a full workup," he said. "Genetic sequencing of every organism present. Complete chemical analysis of the water including trace elements. Environmental monitoring over time. We need to understand what variables are driving this behavior. Temperature, light, chemistry, everything." "Agreed. And we don't tell anyone until we understand what we're looking at. Not colleagues, not friends, not family. No one. Is that clear?" "Why the extreme secrecy?" "Because if this is what I think it might be, premature disclosure could end both our careers. People will assume contamination first. They'll assume we're incompetent or delusional, or perpetrating some kind of academic fraud. We need ironclad evidence before we go public. Evidence that's so overwhelming that skeptics have no choice but to accept it. And if it's not what you think it is, then we need equally ironclad evidence to publish without being laughed out of academia. Either way, we need to be absolutely certain before we say anything. What do you think it is?" He looked at me for a long moment. "I don't know, but whatever it is, it's not normal biology." Over the next 2 weeks, Marcus and I established a comprehensive monitoring protocol. This wasn't casual observation anymore. This was systematic science. We took samples every 6 hours, dawn, noon, dusk, midnight. We set alarms that woke us from sleep. We worked in shifts to ensure continuous coverage. We measured temperature, dissolved oxygen, conductivity, nutrient levels, light penetration, and pH at multiple depths. We catalogued every species present, from bacteria to fish. We collected sediment samples from the lake bottom using a coring device that extracted cylinder of mud containing historical records of the lake's ecology. We analysed the chemical composition of the water at parts per billion precision using gas chromatography and mass spectrometry, and we watched the lake change. It started subtly. Algae populations shifted their distribution. Instead of being evenly dispersed throughout the water column as they normally would be, they concentrated in specific areas. The western section of the lake developed dense algae blooms while the eastern section remained clear. There was no obvious environmental reason for this. Light penetration was consistent, nutrient levels were similar, temperature was the same, yet the algae chose sides. Zooplankton altered their migration patterns in ways that made no ecological sense. Normally, these tiny animals move vertically in the water column on a daily cycle, rising to feed in surface waters at night and descending to avoid predators during the day. But the zooplankton in this lake began moving horizontally instead, forming distinct bands at different depths that persisted day and night. Fish began avoiding certain areas entirely. I noticed it first while checking our underwater cameras. We had deployed several along the lake bottom at various depths to monitor fish behaviour. The cameras recorded continuously, 24 hours a day, storing video on large memory cards we retrieved weekly. In the first few days of recording, fish moved randomly throughout the lake, following typical patterns. Northern pike hunted in the shallows near shore where small fish congregated. Walleye stayed deeper during the day, rising to feed at dusk. Yellow perch formed schools in mid-depth water, swimming in loose formations. But after a week, the fish stopped entering the eastern third of the lake. Not gradually, suddenly. One day they were there, visible on all the cameras. The next day, they weren't. It was like an invisible wall had gone up. Fish would swim toward the eastern section, then turn sharply and swim back, as if they had encountered something they didn't like. "Look at this," I told Marcus, showing him the time-stamped footage on my laptop. He watched the video 3 times, rewinding and pausing at key moments. His expression grew more concerned with each viewing. "There's no obvious environmental reason for avoidance," he said. "Temperature is consistent across the lake. Oxygen levels are fine throughout. No visible pollution. No predators in that section that aren't elsewhere. Nothing that should make fish avoid it. But they're staying away. Consistently. Every species. Something is in that section of the lake that they perceive as a threat or an obstacle. Something we're not measuring." We took additional water samples from the eastern section, testing for everything we could think of. Heavy metals, organic pollutants, industrial chemicals, agricultural runoff, petroleum products, nothing. The water chemistry appeared identical to the rest of the lake, but under the microscope the microbial populations were different. Not different species, different behaviour. They were more active, more coordinated, and they were building something. The structures had evolved beyond simple geometric patterns. Now they were creating 3-dimensional architectures that extended through the water column. Bacteria formed long chains that anchored to algae, which attached to diatoms which connected to protozoa. The result was a complex network, like scaffolding or a web, that extended through the water in organised matrices. "It's building infrastructure," Marcus said quietly, staring at the microscope. "Infrastructure for what?" "I don't know, but it's purposeful. This isn't random growth. This is construction. Deliberate organisation towards some end goal we don't understand." We began to notice other changes as well. Microorganisms began forming larger structures that were visible to the naked eye. Filaments of coordinated bacteria stretched between our sample containers. If we placed 2 collection bottles in the water 10 feet apart and left them overnight, by morning thread-like connections would form between them, created by billions of individual organisms aligning themselves into living bridges. Clusters of diatoms created crystalline formations that refracted light in spectacular ways. When the sun hit them at certain angles, they would sparkle beneath the water's surface, like someone had scattered diamonds or crushed glass. It was beautiful, unnatural, wrong. The ecosystem was reorganizing itself, and it was doing so in response to us. "It's responding to observation," Marcus said one night as we reviewed the day's data by lantern light. The generator had run out of fuel and we hadn't bothered to refill it. "What do you mean?" "Every time we take a sample, the system adapts to our methodology. It's learning how we work. Watch this." He pulled up a spreadsheet showing the timing of our sampling events, overlaid with measurements of microbial activity in different parts of the lake. The correlations were striking. See? The morning after we started taking samples from the north end, microbial populations in the north increased by 37%. When we moved our sampling to the south end 3 days later, southern populations increased by 42% within 12 hours. When we started using nets instead of bottles to collect plankton, within a day the plankton had developed avoidance behaviours. They learned to swim away from nets. I studied the data carefully. The correlations were undeniable, the patterns were clear, the timing was too consistent to be coincidence. "It's learning," I said, "not through intelligence, not the way animals learn through trial and error, but through chemistry. The entire ecosystem is communicating via chemical signals we barely understand. Pheromones, enzymes, molecular markers, a language written in compounds dissolved at parts per billion, and it's using that language to coordinate responses to external stimuli. To us. Yes, to us, to our presence, to our activities, to our sampling procedures. It's studying us while we study it." The implications were disturbing. Marcus started keeping a detailed log that went beyond scientific observations. He recorded personal information, stress levels on a scale of 1 to 10, sleep quality and duration, mood states throughout the day, physical symptoms like headaches or fatigue. He asked me to do the same. "Why?" I asked. "Because I think it's reacting to more than just our equipment and procedures. I think it's reacting to us as organisms, to our biological state." "That's impossible." "Is it? Think about what we know. Humans produce pheromones. We exhale chemical signals with every breath. Carbon dioxide, yes, but also volatile organic compounds that vary based on our diet, health, and emotional state. Our sweat contains thousands of compounds. Stress hormones like cortisol can be detected in saliva, sweat, even skin oils. Every time we handle equipment or wade into the lake for samples, we're introducing our chemistry into the system. We're not separate from the ecosystem. We're part of it. You think the lake can sense our emotions? I think the lake can sense chemical changes, and emotions produce chemical changes. Fear increases cortisol and adrenaline. Happiness increases dopamine and serotonin, which can be metabolized and excreted. Anger increases testosterone. Every emotional state has a chemical signature, and some of those chemicals enter the environment through our breath and sweat and skin. But that's trace amounts, parts per trillion maybe. And microorganisms can sense chemicals at those concentrations. Bacteria can detect single molecules. They've evolved to be exquisitely sensitive because their survival depends on finding food sources and avoiding toxins in dilute environments. If they can sense one molecule of nutrient in a million molecules of water, they can certainly sense our pheromones. He was right. I knew he was right. It made sense from a pure biochemistry standpoint. Over the following week, we discovered an undeniable pattern. On days when we were calm and focused, when we had slept well and weren't stressed, the lake's chemistry stabilized. Nutrient cycling became more efficient, with nitrogen and phosphorus moving smoothly through the food web. Species diversity increased as different organisms found their ecological niches. The microbial structures we observed appeared more organized and stable, with clear patterns and symmetrical arrangements. On days when we were frustrated or anxious, when we had slept poorly or argued about procedures or worried about what we were seeing, the system became turbulent. Algae blooms appeared overnight, turning sections of water green or brown. Dissolved oxygen levels fluctuated wildly. Fish exhibited stress behaviours, swimming erratically or huddling in tight schools in corners of the lake. The microbial structures fragmented and reformed in chaotic patterns. The lake was mirroring our emotional states. "This is insane," I said, staring at the correlation data Marcus had compiled. The graphs showed our cortisol levels measured through saliva samples, plotted against chemical changes in the lake water. The lines matched almost perfectly with a lag time of approximately 6 hours. "Is it?" Marcus pulled up another graph showing our heart rate variability, a measure of nervous system activity plotted against dissolved oxygen fluctuations in the lake. Again, the correlation was striking. That's coincidence. It has to be. For 2 weeks straight, every single day, the correlation coefficient is 0.97. That's stronger than most cause and effect relationships in biology. That's stronger than the link between smoking and lung cancer in early studies. I had no answer. I wanted to argue. I wanted to find a flaw in his analysis, but the data was solid. His methodology was sound. The correlations were real. We started experimenting deliberately to test the hypothesis. We meditated for 30 minutes before taking morning samples, using breathing exercises to lower our heart rates and stress hormones. We listened to calming music. We did gentle yoga stretches. We tried to be as relaxed and peaceful as possible. The lake responded. Within 6 hours, the water chemistry shifted towards stability. The microbial structures became more organized. Fish behavior normalized. It was as if the lake itself calmed down. Then we tried the opposite. We deliberately induced stress. We argued with each other about trivial things like equipment storage and sample labeling. We worked through sleep deprivation, staying up for 36 hours straight on purpose. We solved difficult math problems under time pressure, generating anxiety. We watched stressful videos. We made ourselves as agitated as possible. The lake responded again. The water became chemically chaotic. Microbial activity spiked dramatically. Algae blooms appeared in patches. Oxygen levels went haywire, supersaturating in some areas and dropping dangerously low in others. The structures we had been observing began to fragment and reorganize in more complex fractal patterns that seemed almost frantic. "It's reading us," Marcus said. "Not our thoughts, not our intentions, not our conscious minds, but our biochemistry. It's monitoring us the way we monitor it. We're not separate observer and observed. We're participants in a system that responds to our presence." "How is that possible?" "I don't know. Pheromones in our sweat when we handle equipment. Vibrations from our heartbeats transmitted through the boat hull when we're on the water. Chemical traces in our breath mixing with water vapor at the surface. Skin cells we shed constantly that dissolve in the lake. Maybe all of it combined into a chemical portrait of our physiological and emotional states. But why? Why would an ecosystem evolve to monitor humans? We've only been in this region for a few hundred years. Evolution doesn't work that fast." He looked at me for a long moment. His expression was troubled, uncertain, maybe frightened. "What if it didn't evolve?" he said. "What if it was designed?" Chapter 3. The Biological Interface. The theory formed slowly, over late-night conversations fueled by too much instant coffee and too little sleep. What if the ecosystem wasn't native to this lake? What if it had been seeded here, deliberately, by something intelligent? Not a spacecraft, not a probe in any traditional sense of metal and electronics and machines, but a biological sensor array. Something organic that could integrate seamlessly into an existing environment. Something that could study life by becoming part of the food chain, by living among the organisms it was monitoring. Something that could watch and learn for centuries without ever being noticed because it looked exactly like natural biology. A living surveillance system. "You're talking about aliens," I said. We were sitting on the dock at midnight. watching stars reflect in the lake's mirror-smooth surface. The Milky Way was visible, a river of light across the sky. In the city, you never see stars like this. I'm talking about observation without contact, Marcus replied. Think about it from a xenobiological perspective. If you wanted to study an emerging intelligent species without influencing their development, you wouldn't send a ship. You wouldn't land on their planet and start asking questions. That would contaminate the experiment. You'd be introducing new ideas, new technology, new possibilities. You'd fundamentally alter their trajectory. So what would you do? You'd observe from a distance. But even that has problems. If you're watching from orbit, you can't see what really matters. You can track populations and technology, but you can't understand culture or psychology or the subtle details of how a species thinks and behaves. For that, you need to be present. You need to be close. You need to interact at some level. So you'd send spies. You'd send something that could survive for centuries or millennia. Something that could adapt to changing environments as the planet's climate shifted. Something that could gather data over generations without requiring maintenance or refueling. And most importantly, something that would never be recognized as artificial by the species you're studying. A biological system. Exactly. What better way to study aquatic life forms than to become part of the aquatic ecosystem? To live in their lakes and rivers and oceans? To be present in every sample they collect, hiding in plain sight among billions of native organisms? To be so ordinary, so normal-looking that nobody would ever question your presence? But how would it transmit data? How would it report back? I don't know. Maybe it doesn't. Maybe it stores information in genetic sequences, in the DNA of the organisms themselves. Maybe it waits for periodic retrieval, or maybe it has some method of communication we can't detect. Quantum entanglement, gravitational waves, something beyond our current physics. That's pure speculation, based on evidence. We've documented impossible biology, coordinated behavior that violates everything we know about single-celled organisms, overnight morphological changes that break the rules of evolution, chemical communication networks that operate at a level of sophistication we can barely measure, and most significantly, a system that appears specifically designed to study higher life forms by monitoring their biochemistry and responding to their presence. I wanted to argue, but I couldn't. The data supported his hypothesis, or at least it didn't contradict it. We had no proof of extraterrestrial origin, but we had no naturalistic explanation either. No terrestrial biology we knew of behaved this way. No known organisms could coordinate like this. No evolutionary pressure would create such specific, targeted behaviours. If you're right, I said, then this has been here for how long? Unknown. Could be decades. Could be centuries. Could be since before humans existed. Could be since before any intelligent life existed on Earth. Maybe it was seeded here billions of years ago, programmed to activate when complex life evolved. Maybe it's been watching the entire history of life on this planet, and nobody noticed? Why would they? It looks like any other lake. The microorganisms look like any other microorganisms until you study them very closely with modern equipment. And who studies boring remote lakes closely? Almost nobody. That's the whole point. It's perfectly camouflaged. It's boring by design. It doesn't draw attention. It sits here year after year, century after century, quietly collecting data on everything that lives in or near it. So what's its purpose? Observation, data collection. The organisms aren't just adapting to us, they're documenting us, recording our chemistry, cataloguing our responses, building a biological database of human behaviour, recording how we move, how we work, how we respond to discovery, what stresses us, what calms us, everything. To what end? Who knows? Maybe we're part of a larger survey. Maybe whoever sent this is studying thousands or millions of planets, collecting information on every emerging intelligent species in the galaxy. Maybe they want to understand how life evolves across different environments. Maybe they're building a taxonomy of consciousness, a natural history of intelligence across the universe. Maybe they're just curious. Or maybe it's a threat assessment. Marcus nodded slowly. That's the concerning possibility, yes. If this is alien technology, we have to assume it's reporting back somehow, transmitting data, which means somewhere, something is compiling information about humanity, about our biology, our behavior, our capabilities, our vulnerabilities, and deciding what, whether we're interesting, dangerous, worth further study, worth contact, worth... He didn't finish the sentence. He didn't need to. We both understood the implications. We faced a choice. Report our findings and trigger a governmental response. The lake would be immediately quarantined. The ecosystem would be destroyed or contained. Scientists would descend en masse. Military oversight would follow, assuming anyone believed us, which was far from guaranteed. More likely, we'd be dismissed as incompetent or delusional, and the lake would be quarantined as a biohazard while better researchers tried to figure out what was actually happening, or stay silent and preserve the system. Marcus favoured disclosure. I favoured silence. We argued for 3 days. This could be the most important discovery in human history, he said. We were in the cabin, rain drumming on the roof. Another storm had moved in. Proof of extraterrestrial intelligence, evidence of technology beyond our comprehension. We have a responsibility to report it, to tell humanity that we're not alone, that we're being watched, that first contact may have already happened. Or it could be a misunderstanding that gets a unique ecosystem killed, I countered. We don't have proof of alien origin. We have unusual biology and a hypothesis. That's not enough to justify destroying it. What if we're wrong? What if there's a natural explanation we haven't discovered yet? We'd be responsible for the destruction of something irreplaceable based on speculation. And if we're right, if this is genuinely alien, if it's reporting on humanity to something out there, don't we have an obligation to inform our species? Don't they deserve to know they're being watched? To what end? So we can destroy the only communication channel we might have with whoever sent it, so we can prove we're exactly as primitive and violent as they might suspect. If this is first contact, the worst thing we could do is respond with fear and destruction. You're asking me to sit on the most significant finding of my career, to hide what could be proof of alien life because you're afraid of what humans might do. I'm asking you to consider that maybe our first contact with alien intelligence shouldn't be us killing it. I'm asking you to think about what this says about whoever sent it. They've been watching us for who knows how long without interfering, without invading, without making demands, just observing, learning. That suggests patience, restraint, maybe even respect for our development. Or it suggests they're gathering intelligence before invasion. Has it hurt anyone? Has it hurt anything? It's been here for years, maybe centuries, and the lake is perfectly healthy. The fish population is stable. The ecosystem is thriving. It's not a threat. It's just watching. And if we tell people, they'll destroy it out of fear, and we'll lose any chance of learning from it or communicating with whatever sent it. Marcus leaned against the cabin wall, exhausted. Rain leaked through a gap in the roof, dripping into a bucket we'd placed on the floor. The sound was rhythmic, hypnotic. You're asking me to choose between my career and your philosophy, he said. I'm asking you to choose between discovery and destruction, between fear and hope, between proving we're violent primitives and proving we're capable of wisdom. And if I say no, if I report this anyway, then you'll be responsible for whatever happens next. We were at an impasse. Neither of us slept that night. We sat in the cabin, listening to rain, both lost in our own thoughts. Then, at dawn, the lake made the decision for us. Chapter 4. The uncomfortable conclusion. On day 32 of our study, everything changed. I woke at dawn to silence. The rain had stopped. The generator was off to conserve fuel. The cabin was cold. I made coffee on the propane stove and went through my usual routine, checking the monitoring equipment and reviewing overnight data from the automated sensors. Everything appeared normal. Then I took morning samples. Under the microscope, the microorganisms looked different, not morphologically, behaviourally. The coordination had stopped. The organisms were moving randomly again like normal microorganisms. No formations, no geometric patterns, No structures, just chaotic, independent movement. Diatoms drifted with water currents. Cyanobacteria grew in irregular chains without alignment. Protozoa moved independently without maintaining spacing. It was as if someone had flipped a switch. I thought my equipment was malfunctioning. I prepared fresh samples using different water sources. Same result. I called Marcus over. He was still asleep, curled up in his sleeping bag on the floor. He'd given me the cot. "Something's wrong," I said. He sat up, groggy. "What?" "They've stopped. Look." He came to the microscope, rubbing sleep from his eyes. He looked through the eyepiece for a long moment. "They're behaving normally," he said. "Exactly. Why?" We spent the entire day taking samples from multiple locations at multiple depths. Every sample showed the same thing. The coordinated behaviour had ceased. The adaptive responses had ended. The chemical communication network that we documented for weeks had gone silent. The lake had become ordinary. We ran every test we could think of. Temperature unchanged, water chemistry stable, no pollution events, no environmental stressors. Nothing had changed in the physical environment. But the biology had reverted to normal. "What happened?" I asked. Marcus reviewed the data from the previous 24 hours, looking for anomalies or patterns. He pulled up graphs and charts, compared chemical measurements, checked our logs. "I think it finished," he said quietly. "Finished what?" "Observing us. It collected enough data. There's nothing more to learn from our presence. We've been here for over a month. We've provided it with thousands of observations of human behaviour, samples of our chemistry every 6 hours, documentation of our methodologies and procedures, records of our emotional states and physiological responses. It's learned everything it needs to know about us as researchers, as humans, as a sample of our species." So it just stopped, or went dormant, or transmitted its findings and entered a passive state. Think about it. If this is truly alien technology designed to study life, it would be programmed to be efficient. Don't waste energy monitoring empty locations or redundant data. When subjects are present and interesting, activate and study them intensively. When you've learned what you need, deactivate and wait for the next interesting subject. You're saying we were interesting. Now we're not. I'm saying we provided useful data. Now we've been catalogued, filed, recorded. The monitoring system has moved on to waiting mode. The implications settled over us like a heavy cold blanket. If Marcus was right, if this was truly alien technology, then we had just participated in first contact without even realising it. We had been observed, documented, catalogued, and studied by something that understood us better than we understood ourselves. And now it was done with us. We were yesterday's news, old data, not interesting enough to maintain active surveillance. And somewhere, in some database light years away, there was a file on us, on our species, on our behaviour and biology and psychology. Everything we were, reduced to data points and measurements. What did it learn? I wondered aloud. Everything, Marcus said. How we work, how we think, how we respond to discovery, what stresses us, what calms us, our chemistry, our patterns, our limitations, our capabilities, everything that can be inferred from observing 2 researchers for 32 days. We stayed another week, hoping the activity would resume. It didn't. The lake remained biologically normal. Fish returned to their regular patterns throughout the entire lake, including the eastern section they had previously avoided. The invisible barrier was gone. Algae growth stabilized and redistributed evenly. Every measurement fell within expected parameters for a healthy northern temperate lake in late spring. It was as if the previous month had never happened, except we had the data. Thousands of photographs and videos, hours of documentation, detailed chemical analyses, genetic sequences, behavioral observations, everything meticulously recorded and backed up on multiple drives. The evidence was undeniable. Something had happened here. Something anomalous. Something that defied conventional biology. But without active phenomena to demonstrate, without the behaviour continuing, would anyone believe us? We filed our final report very carefully. We described the observations as transient biological phenomena of unknown origin requiring long-term monitoring. We noted that coordination and adaptive responses had been documented extensively over a 32-day period before ceasing spontaneously. We recommended the lake be added to a watch list for periodic reassessment. We suggested further study was warranted but provided no hypotheses about extraterrestrial origin or intelligent design. We published nothing in peer-reviewed journals. The data would never survive peer review. We would be laughed out of academia. We told no one about our alien hypothesis. That would end our careers immediately. Marcus returned to his university position 3 days later. We shook hands in front of his truck. The sun was shining. Birds were singing. The lake looked beautiful and peaceful and utterly ordinary. "What are you going to do?" he asked. "Finish my degree, find a job, keep my mouth shut. And if it happens again, if you find another lake like this, I'll document it, quietly, and I'll let you know. We could be missing the opportunity of a lifetime here, the chance to prove we're not alone. Or we could be preserving the only communication channel we have. Sometimes the bravest thing isn't speaking, it's staying silent and waiting." He nodded. He understood, even if he didn't agree. I watched his truck disappear down the 2-track path through the pines. Then I finished packing my equipment and left that place. I never told my supervisor about the alien hypothesis. I wrote up my master's thesis on extremophile bacteria in geothermal environments, making no mention of Manitoba. My committee praised the work. I graduated with honours. I got a job with an environmental consulting firm, travelling to contaminated sites and assessing cleanup efforts. Useful work, important work, meaningful work. But every time I looked at a body of water, I wondered. Chapter 5. The Waiting Game. 6 months after leaving the lake, I couldn't stop thinking about it. I was working on a contamination assessment in northern Alberta, testing water quality near an old mining site. Standard environmental work, testing for heavy metals and industrial pollutants, making sure the cleanup was effective, nothing unusual. But I kept taking extra samples, running additional tests, looking for patterns, and one day, I found them. Diatoms moving in loose formation, only for a few hours, then it stopped. I was alone on the site. Nobody else saw it. I documented everything on my phone, photographs, videos, detailed notes. Then I encrypted the files and stored them on an external drive. A week later, in a river in Saskatchewan, I observed overnight morphological changes in a population of cyanobacteria. Shell structures that were smooth one day, ridged the next, then the next day, back to normal. Again, I was the only observer. Again, I documented everything. Again, I told nobody. It was happening elsewhere. Not just in that one lake, but in other water bodies, other locations, other ecosystems, brief glimpses, fragments. Nothing like the sustained activity Marcus and I had observed. But they were there. Evidence that something unusual was present in freshwater systems across North America. Something that activated occasionally, observed briefly, then went dormant. I started building a private database. Locations, dates, species affected, duration of phenomena, environmental conditions, everything I could measure and document. I reached out to Marcus through encrypted email. I shared my observations. He responded with his own. He had found 3 lakes near his university with interesting characteristics: transient coordination, brief structural formations, overnight adaptations, each episode lasting days to weeks before ceasing. We weren't the only ones observing, but we were probably the only ones who understood what we were seeing. "I think they're everywhere," I wrote to him, "not just in that one lake, but distributed across the continent, maybe the planet, monitoring stations in every major watershed, watching, learning, reporting." His response came 2 days later. "I've been thinking the same thing. I've documented 17 locations across 3 provinces, all showing similar patterns: transient activation, brief observation periods, then dormancy. It's like a network, a planetary surveillance system. But why activate sometimes and not others? I think human presence triggers activation, specifically human observation. It only becomes active when we're paying attention, when researchers are present and engaged in study. The rest of the time, it remains dormant to conserve energy and avoid detection, which means it's been watching humanity for a very long time, probably since before we developed science, probably since we were still hunter-gatherers, maybe longer. The implications were staggering. If this was true, if monitoring systems were distributed across the planet, then humanity had been under observation for thousands of years, maybe tens of thousands, maybe longer. Every lake, every river, every ocean, potentially watching, potentially learning, potentially reporting to something far away about the development of an interesting species on an interesting planet. We were specimens in a cosmic zoo, subjects in an experiment we didn't know we were part of, and the watchers were so patient, so subtle, so perfectly camouflaged that we'd never noticed. Until now. I began collaborating with Marcus remotely. We developed a methodology for identifying potential monitoring sites. We looked for lakes that had never been studied, remote locations, stable ecosystems, places that were boring and unremarkable, places nobody would pay attention to. We found dozens. Some showed activity when we visited, brief episodes of coordination. Most remained dormant. We documented everything. We built maps. We collected genetic samples for comparison. We analysed water chemistry looking for commonalities. A pattern emerged. The monitoring systems weren't randomly distributed. They were strategically placed in watershed systems across the continent, locations that would allow them to sample a wide range of biological diversity. Lakes connected to major river systems, watersheds that drained large geographic areas, locations where water flowed through, carrying chemical signals from upstream ecosystems and populations. It was a network, a surveillance grid, optimally designed for maximum coverage with minimum resources, elegant, efficient, invisible. 3 years after my initial fieldwork, I went back to the lake in Manitoba. I didn't tell Marcus this time. I needed to see it alone, to reconcile what I had experienced with what I had become, to face the place that had changed my understanding of reality. The cabin was still there, more weathered than I remembered. Someone had patched the roof poorly. The dock had rotted further, sagging dangerously. The outhouse had finally collapsed completely. But the lake looked exactly the same, clear, peaceful, unremarkable. I set up my equipment in the cabin and took samples. For 3 days I found nothing unusual. Normal microbial populations, normal behaviour, normal chemistry, just a boring northern lake doing what boring northern lakes do. On the 4th day, I decided to try something different. I sat on what remained of the dock and meditated, deep breathing, clearing my mind, lowering my stress hormones deliberately, making myself as calm and receptive as possible, trying to signal to whatever might be watching that I was present and attentive and open to observation. Then I took a sample. Under the microscope, the organisms were coordinating. Not dramatically. Not like the sustained activity from 3 years ago, but subtly. Diatoms maintaining loose formations, cyanobacteria showing slight alignment, protozoa with more regular spacing than random chance would predict. It was responding to me. I spent the next 2 hours sitting motionless on the dock, maintaining that calm state of awareness. With each sample I took, the coordination increased slightly. The organisms were becoming more active, more organised, remembering perhaps how to interact with human observers. Then I deliberately broke the calm. I stood up quickly. I paced. I thought about stressful things from my life, failed relationships, career anxieties, the weight of keeping secrets. I let anxiety flood my system. I took another sample. The coordination had decreased. The organisms were moving more chaotically, reacting to my stress just as they had 3 years ago. It was still there, still watching, still responding to human presence, still learning. I wanted to feel vindicated. Instead, I felt profound sadness, because I realised something Marcus and I had never fully confronted during all our late-night theories and analysis. We weren't the subjects of study to assess our threat level. We weren't being monitored to determine if we were worth contacting. We were being watched because something out there found us interesting. The way we might study insects or birds, the way naturalists observe animals in their habitat. Not as potential equals, not as threats or allies, not as beings worthy of direct contact, as curiosities, as specimens in the largest natural history museum in the galaxy, catalogued, documented, preserved in data, interesting enough to watch, but not interesting enough to disturb with actual communication. That night, I sat by the lake and looked at the stars, billions of them scattered across the sky, the Milky Way a river of light, each point of light potentially a sun with planets orbiting it. And somewhere among all those stars something was compiling reports on all of them, building a database of life, documenting the universe's endless experiments in biology and consciousness, watching as species rose and fell, as civilizations emerged and collapsed, as life adapted to every possible environment, taking notes, making observations, building a cosmic catalogue, and Earth was just one more entry. Humanity just one more interesting variation in the grand diversity of life, worth watching, worth documenting, but not worth direct contact. Not yet. Maybe not ever. I never told Marcus about my return visit. I never filed a report. I simply went home, filed away my data with all the rest, and returned to my normal life. Because what would disclosure accomplish? The monitoring systems, if that's what they are, pose no threat. They don't harm, they don't interfere, they don't manipulate, they simply watch and learn and record. And maybe that's enough. Maybe being observed, being studied, being remembered by something vast and ancient and utterly alien is a form of validation. We exist. We matter. Even if only as data points in someone else's research project. Even if only as footnotes in a cosmic catalogue of carbon-based life. Epilogue. Contact without witnesses. 5 years have passed since my first visit to that lake. I'm 32 now. Still working in environmental consulting. Still travelling to contaminated sites across North America. Still taking samples from lakes and rivers. Still looking for signs. And occasionally I find them. Brief moments of coordination. Transient geometries. Adaptive responses that vanish as quickly as they appear. In lakes across Manitoba and Saskatchewan. In rivers through Alberta and Ontario. In reservoirs in British Columbia. In streams in the northern United States. The monitoring systems are everywhere. Or they're nowhere. And I'm seeing patterns in randomness because I want to believe we're being watched. Because I want to believe we're not alone in the universe. Because I need to believe that somewhere, someone cares enough about us to pay attention. I honestly don't know which possibility disturbs me more. Marcus retired last year. He sent me his complete database before he left academia. 43 locations across 7 countries where he had documented unusual aquatic biology. Some observations lasting hours, some lasting weeks, all eventually returning to normal. Transient phenomena that could be anything or nothing. I don't know what to do with this, his final email said. Publishing would destroy whatever credibility I have left. Not publishing feels like betraying everything science stands for. I'm giving it to you. Maybe you'll figure out the right choice. Maybe you'll be braver than I was. Maybe you'll find the proof we never could. I haven't. The data sits on encrypted drives in my desk drawer. Thousands of observations, hundreds of hours of video, chemical analyses, genetic sequences, behavioral studies, maps showing locations across the continent, proof of nothing, evidence of everything. Sometimes I pull it out and review it, looking for patterns I missed, trying to find the smoking gun that would make it all undeniable, the one piece of data that would prove extraterrestrial origin beyond any doubt. it's not there. Or if it is, I'm not smart enough to see it. I think about that lake constantly. I dream about it. In my dreams, I'm underwater, looking up at the surface, watching shadows move across the sunlit ripples, and I can feel the presence of something vast surrounding me. Not threatening, not particularly interested, just aware, watching, always watching, recording everything. Tomorrow, when you walk past a pond, a stream, a lake you've known your whole life, consider the possibility that it knows you too, that it's been watching since before you were born, recording, documenting, learning, not with malice, not with intent to harm, not even with any particular interest in you as an individual, just with the patient, chemical curiosity of something designed to understand, to catalogue, to document the universe's endless variety of life. And maybe, just maybe, when it learned enough about us as a species, it sent that information somewhere far away, where something is compiling reports on billions of worlds across billions of years, building a taxonomy of consciousness, a catalogue of intelligence, a natural history of the universe itself, and we're in there somewhere, filed under observed civilizations, carbon-based, water-dependent, with detailed notes about our chemistry, our behaviour, our psychology, our potential, our limitations, with a conclusion that reads something like, recently technological, shows promise, capable of observation and analytical thought, prone to anxiety and conflict, requires continued monitoring, current status, interesting but not yet worthy of direct contact, recommend passive observation continue until further development warrants reassessment. The lake still sits in northern Manitoba, surrounded by pine forest, reflecting clouds and sky. Still clear, still quiet, still perfectly terrifyingly ordinary. And somewhere beneath its surface, dormant microorganisms wait. For what? I don't know. Maybe they're done with us. Maybe they've learned everything they need. Or maybe they're just between observation periods, waiting for the next phase of human development, waiting to see what we become, waiting to record our next evolutionary step, our next technological breakthrough, our next significant change. Because the scariest thing about first contact isn't that it might happen someday, it's that it might have already happened centuries or millennia ago, and we were the ones being studied all along, by something so patient, so subtle, so perfectly camouflaged as nature itself that we never even knew to look, until a grad student with a microscope happened to look at the right moment and saw something that shouldn't have been there, something that was watching back. The lake remembers, even if we choose to forget. It remembers every person who swam in its waters, every fisherman who cast a line, every researcher who took a sample, every child who skipped stones across its surface. It remembers all of us, every chemical signature, every emotional state, every stress response, every moment of joy or fear or curiosity or boredom, all recorded, all documented, all transmitted somewhere to be analysed and filed away. And somewhere in the depths of space, light years beyond our ability to reach or even detect, someone knows exactly what it learned about us, about our species, about our world, about our place in the vast ecology of intelligence that might span the universe. Sleep well tonight, and tomorrow, when you see a body of water you've known forever, maybe take a closer look. Not because you'll find anything, you won't, they're too good at hiding, but because something might be finding you, measuring you, learning you, just like it learned us, in a lake that learned us, one chemical signature at a time, one observation at a time, one species at a time, and the watching never ends. It only pauses, waiting for the next interesting subject to come along, the next question to be asked, the next mind curious enough to look closely and see what's really there beneath the surface of the ordinary, beneath the camouflage of the mundane, in the depths where something patient and alien and utterly fascinating has been hiding for longer than we can imagine. Watching, always watching, forever watching, until the day we're finally interesting enough to talk to, or until we prove we're not.
Before we begin tonight's story, I want to take just a moment to ask for your support. If you're enjoying this content, using your hype points on this video helps the channel more than you could possibly know. The algorithm notices engagement like that, and it makes a real difference in reaching new listeners. If you're tuning in on Spotify, leaving a review truly helps us out so much. And if you feel like it, drop a comment letting us know what time it is where you are and where in the world you're listening from. We absolutely love seeing where everyone is tuning in. It connects us all in this strange community of night listeners. And of course, if you enjoy the content, subscribing means we can keep bringing you these stories week after week. Now let's get into tonight's encounter. There are certain jobs that exist in the margins of society, work that happens when most people are asleep, labour that keeps infrastructure running while the world dreams. I spent 3 years working night shifts for a company that calibrated industrial sensors across remote facilities, oil refineries, water treatment plants, agricultural monitoring stations scattered across hundreds of miles of empty land. The work was repetitive and technical. Each night followed the same rhythm. Arrive at the site, log into the system, run diagnostics, adjust sensitivity thresholds, document everything. The company was meticulous about procedure. Every reading logged with timestamps, every adjustment tracked in triplicate. Deadlines were strict, protocols were mandatory. Deviation from schedule could cost contracts worth millions. I preferred night work. Fewer people, fewer interruptions. Just me, the equipment, and the steady hum of machinery doing what it was designed to do. The facilities were usually automated. My job was to ensure the automation stayed accurate. Sensors drift over time. Temperature fluctuations, humidity, electromagnetic interference from nearby equipment. Everything affects precision. Calibration corrects for that drift. It returns instruments to baseline accuracy. Nothing about that particular night suggested anything unusual. I had 17 sensors scheduled across 4 locations, standard maintenance window, 6 hours to complete the work. The weather was clear, equipment was functioning normally. I had done this exact route 40 times before. I clocked in at 2200 hours. The first 3 sites went exactly as expected. By midnight, I was ahead of schedule. The 4th location was a water monitoring station, 15 miles outside of town, middle of nowhere. surrounded by scrub brush and empty farmland. The nearest building was 4 miles away. I pulled up to the gate at midnight. Everything looked normal. Chapter 1. The Scheduled Anomaly. The monitoring station was a small concrete building about the size of a garden shed. Most of the actual equipment was underground or mounted on exterior towers. My work happened at the control terminal inside. I unlocked the door, flipped on the lights, and logged into the system. 17 sensors total at this location. Soil moisture, groundwater levels, rainfall accumulation, chemical composition, temperature at various depths, standard agricultural monitoring. The kind of data that influences irrigation schedules and water rights across 3 counties. I started the calibration sequence at 12:23. The first 6 sensors responded perfectly. Green lights across the board, readings within expected parameters, adjustments minimal. I was documenting the 7th sensor when I noticed the anomaly. Sensor 12 was failing calibration, not in the usual way. Equipment failure presents as chaos, random noise, erratic spikes, silence. This was different. The sensor was returning precise, consistent readings, but they were wrong. Exactly 3.7 degrees off baseline. Every single time. No variation, no drift. Just that same offset. Over and over. I ran the sequence again. Same result. 3.7 degrees. I checked the physical connections. Solid. No corrosion. No loose cables. I rebooted the entire system. The anomaly persisted. Sensor 12. 3.7 degrees. Perfectly consistent. Perfectly wrong. The error was localized. The sensors on either side of it functioned flawlessly. Sensor 11 recorded normal readings. Sensor 13 was within tolerance. Only 12 was affected. The system flagged it as environmental interference. Not equipment malfunction, not software error. Environmental. That designation bothered me. Environmental interference implies something external is affecting the sensor. Something in the physical environment around the probe. But what could cause such a precise offset? I had seen electromagnetic interference before. It creates noise, static, random fluctuations. This was surgical, deliberate, as if something was intentionally skewing the reading by exactly that amount. I decided to inspect the physical site. Sensor 12 was located about 200 feet from the building. A simple probe driven into the ground, connected by buried cable. I grabbed my flashlight and headed out. Chapter 2. The light that isn't light. The night was perfectly still. No wind, no clouds, just stars and silence. My flashlight cut through the darkness as I walked the cable path towards Sensor 12. The ground was flat, dry grass and loose dirt. Nothing unusual. I was about halfway to the sensor location when I noticed the illumination. At first I thought it was moonlight, but the moon was only a thin crescent. Not bright enough to cast the kind of light I was seeing. This was different. Softer. It had no apparent source. I stopped walking and turned off my flashlight. The illumination remained. A faint glow that seemed to come from everywhere, and nowhere simultaneously. It did not cast shadows the way normal light does. Objects were visible, but they did not create darkness behind them. It was as if the light was bending around things rather than being blocked by them. I moved toward the sensor location. The illumination grew slightly stronger, still diffuse, still sourceless. I reached the probe and knelt down to inspect it. Everything appeared normal. The casing was intact, the ground around it undisturbed. But the light was undeniable now, visible even with my eyes closed, a gentle pressure against my eyelids. I stood and walked in a slow circle around the sensor. The light did not change intensity based on my position. It was not directional. I tried to determine where it was strongest. Every direction seemed equally illuminated. I moved closer to the probe. The light remained constant. I stepped back. Still the same. Then I walked directly at where the light seemed most concentrated. As I approached, it receded. Not quickly, not dramatically, but definitely moving away from direct engagement, like trying to grab fog. The closer I got to any specific point, the more the illumination shifted elsewhere. Always present, never quite touchable. I spent 20 minutes trying to document this with my phone camera. The footage showed nothing, just darkness and the beam of my flashlight. Whatever I was perceiving, the camera could not capture it. I returned to the building. The moment I crossed the threshold, the illumination vanished completely. Chapter 3. Time slips in small ways. I sat at the terminal trying to make sense of what I had experienced. My watch showed 1:15. That seemed wrong. I had left the building around 12:40. I had been outside for 20 minutes, maybe 25. It should have been 1:05 at the latest. I checked the system logs. They showed a gap in my activity from 12:41 to 1:17. 36 minutes, nearly 40. I had lost time, not hours, not days, just minutes, enough to notice, enough to create discrepancy, not enough to trigger any alarms. I tried to reconstruct my actions, walking to the sensor, inspecting the probe, circling the area, attempting to film, even accounting for thorough investigation. I could not stretch those activities to fill 40 minutes, 15 minutes, maybe 20 if I was being extremely methodical. Not 40. I checked my watch against the system clock. They matched now. Both showed 1:18. I looked at my phone. Same time. Everything synchronized, except for that missing window between 12:41 and 1:17. I attempted to contact my supervisor via radio. No response. I tried twice more. Nothing. The radio was functioning. I could hear static when I keyed the microphone. But no one answered. I checked the schedule. My supervisor was supposed to be on duty, available for contact during all maintenance windows. Radio silence was unusual. I moved on to the remaining sensors. They calibrated normally. No anomalies, no interference, just standard readings and routine adjustments. I completed the work at 1:53. According to my original schedule, I should have been done by 1:30. I was behind, but not by much. I filed my report from the terminal. Sensor 12 listed as requiring follow-up. Environmental interference, cause unknown. Recommended secondary inspection during daylight hours. Everything documented according to protocol. Everything except the light and the missing time. Those details stayed out of the official record. I locked the building and returned to my truck. The drive back was normal. Empty roads, distant lights from farmhouses, radio playing quietly. Nothing unusual, but I kept checking my watch, kept comparing it to the dashboard clock, kept trying to account for those missing minutes. Chapter 4. The sound below. Hearing. The next few nights followed normal patterns, different sights, different sensors, no anomalies. I started to convince myself that the incident at the water monitoring station had been fatigue, misreading the clock, misjudging time in the dark. The illumination was probably some atmospheric phenomenon, temperature inversion, light refraction, something mundane with a scientific explanation. 5 days later, I was scheduled back at the same location. Routine check following my previous report. The company wanted confirmation that sensor 12 was stable. If the interference persisted, they would send a full technical team. If it had resolved, they would close the ticket and move on. I arrived at 22:30, earlier than my previous visit. I wanted extra time, wanted to approach this methodically. The gate was closed but unlocked. I drove up to the building and parked in the same spot as before. The night was warmer, humid. There were clouds on the horizon, but the sky overhead was clear. I unlocked the building and powered up the terminal. The system initialized normally. All sensors reporting. I went straight to sensor 12. I ran a diagnostic without calibration. Just a simple reading. Check. The sensor responded immediately. 3.7 degrees off baseline. Exactly the same offset as before. Perfectly consistent. I started the calibration sequence. The system attempted automatic correction. For a moment, the reading aligned. Perfect baseline. Green light, then it drifted. Back to 3.7. The system tried again. Same result. Brief correction. Immediate drift. After 5 attempts, the system gave up and flagged the sensor for manual intervention. I stood from the terminal and walked to the door. I did not open it yet. I just stood there, looking out through the small window at the darkness beyond. I took a breath and stepped outside. The illumination was already present, stronger than before, still sourceless, still bending around objects rather than casting shadows. I did not bother with my flashlight. I could see perfectly well in that strange light. That was when I felt the vibration. Not heard, felt. A deep rumble below the threshold of audible sound. It resonated in my chest, in my teeth, in the bones of my skull. Subsonic pressure that made my lungs feel compressed. Like standing too close to massive speakers at a concert. Except there was no music, no rhythm. Just constant, unrelenting pressure. I stopped walking and stood completely still. The vibration continued. I looked around. The grass was motionless. No wind. But I could feel movement in the air. Something displacing space. Creating waves of pressure that pushed against me from all directions simultaneously. I noticed the silence. Complete silence. There should have been crickets, frogs, the distant barking of farm dogs. Rural areas are never truly quiet. There is always ambient sound, but not now. Every living thing within earshot had gone silent, as if the entire landscape was holding its breath. I took a step forward. The vibration intensified slightly. I took another step, stronger still. I was walking towards sensor 12, the same direction as before. The pressure built with each step, not painful, but commanding attention, impossible to ignore. I stopped about 50 feet from the sensor. The vibration was overwhelming now. My vision was starting to blur from the subsonic frequency. I could feel my heartbeat synchronizing with the pulse, my breathing matching its rhythm, my body trying to harmonize with something I could not see or hear. I turned around and walked back toward the building. The vibration decreased, step by step, the pressure easing. By the time I reached the door, it had stopped completely. The moment I crossed the threshold, normal sound returned. Crickets, frogs, a dog barking somewhere miles away, the world breathing again. I stood in the doorway for 5 minutes, just listening, just feeling. Everything was normal inside the building. Everything was wrong outside. Chapter 5. The second calibration. I returned to the terminal and pulled up the sensor logs. I wanted to see if the system had detected anything during my time outside. Temperature spike, seismic activity, anything that might explain what I had experienced. The logs showed nothing unusual, all environmental readings within normal range. No anomalies flagged except the persistent offset on sensor 12. I checked the timestamp. It was 23:51. I had been outside for approximately 30 minutes. Again, the same missing time, the same unexplained gap. I was certain I had only been out there for 10 minutes, maybe 15, definitely not 30. I decided to try the calibration sequence one more time. I initiated the process remotely from the terminal. Sensor 12 began its cycle, reading, adjusting, confirming. I watched the numbers scroll across the screen. The offset persisted through the first 3 attempts. Then something changed. The system began adjusting itself before I input any commands. The calibration sequence was running autonomously, not according to the programmed pattern, according to something else, some external parameter I had not specified. The readings flickered. Baseline, offset, baseline, offset, oscillating between the 2 values faster than should have been possible. Then it stabilized. Perfect baseline. No offset, no drift. The sensor was reading exactly as it should. I documented the result, ran a confirmation diagnostic, everything checked out. Sensor 12 was functioning normally. Whatever had been interfering was gone. I completed the calibration on the remaining sensors. All of them responded normally. No anomalies, no strange behavior, just routine maintenance. By the time I finished, it was 1:23. I had been at the site for nearly 3 hours. The work should have taken 90 minutes. I filed my report. Sensor 12 now operational. Interference resolved. Cause unknown. Recommended continued monitoring, but no immediate follow-up required. Standard closing language. Standard documentation. Everything according to protocol. I packed my equipment and headed for the door. I paused with my hand on the knob. Part of me wanted to go back outside to see if the illumination was still there, to feel if the vibration had returned. But another part of me knew that was a terrible idea. I had completed my work. The sensor was functioning. There was no technical justification for additional investigation. I opened the door and walked quickly to my truck. I did not look around, did not slow down, just moved directly from the building to the vehicle. I started the engine and drove away. I checked the rearview mirror once. The station was dark, normal, nothing unusual visible, but I could still feel the vibration in my chest. Hours later, miles away, that subsonic pressure still resonating in my bones. Chapter 6. The shape that refuses focus. I did not return to that site for 2 weeks. The company rotated me to different facilities, different routes. I welcomed the change. I needed distance from that monitoring station, time to process, time to convince myself that everything had a rational explanation. During those 2 weeks, I researched atmospheric phenomena, subsonic resonance, optical illusions caused by temperature gradients. I read scientific papers, watched educational videos, tried to match my experience to documented natural occurrences. Nothing fit perfectly, but several phenomena came close enough to provide comfort. I decided I had witnessed an unusual combination of environmental factors, rare but explicable, concerning but not impossible. The call came on a Thursday. My supervisor needed me to return to the water monitoring station. Sensor 12 was showing anomalies again. Same offset, same pattern. The company wanted me to do a physical inspection, check for animal damage, root intrusion, anything that might be causing interference. If I could not identify the problem, they would schedule a full excavation and sensor replacement. I arrived at the site at 2100 hours, earlier than usual. I wanted to complete the inspection before full darkness. I still had daylight fading into dusk, enough visibility to work without relying entirely on artificial light. I parked and grabbed my inspection kit, tools, testing equipment, camera, documentation tablet, everything needed for thorough site assessment. I walked directly to sensor 12. The illumination was not present yet. Everything looked normal in the failing daylight. I knelt beside the sensor and began the inspection. I checked the casing for cracks, examined the cable connection for corrosion. dug carefully around the probe to verify installation depth. Everything was perfect. Textbook installation. No physical damage, no environmental stress, no reason for the sensor to malfunction. I was photographing the installation when I noticed movement in my peripheral vision. Not direct movement, more like a disruption in the air, the way heat creates shimmer above hot pavement. Except the evening was cool. There was no heat source. I turned my head to look directly at the disturbance. It vanished, completely gone. I returned to photographing the sensor. The movement reappeared, peripheral, persistent, always at the edge of my vision. I stood slowly and stopped looking directly at anything. I let my focus soften, stopped trying to see clearly. The shape became more defined, not solid, but structured. It had dimensions, boundaries, form, something that occupied space, something that refused to be seen directly. Looking at it was disorienting. My eyes wanted to focus, wanted to sharpen the image, but every attempt to do so made the shape dissolve. Only peripheral vision could maintain the perception. Only indirect observation kept it visible. The harder I tried to see it clearly, the more completely it disappeared. I experimented carefully. I turned my head slowly. The shape remained visible as long as I did not look directly at it. I took a step forward. It neither approached nor retreated. It simply was, present, observing, waiting. I reached out my hand. Not toward the shape, just extending my arm into the space where I peripherally perceived it to be. My hand passed through nothing, empty air, but I could feel resistance, not physical, something else, like pushing through a magnetic field, pressure without substance. I withdrew my hand and stepped back. The shape remained constant, not threatening, not aggressive, just there, existing in that narrow band of perception between seen and unseen, present and absent, real and impossible. The sun dropped below the horizon. Full darkness arrived. The sourceless illumination appeared. The shape became easier to perceive, still peripheral, still refusing direct observation, but more defined, more persistent, as if darkness provided better conditions for its visibility than light. Chapter 7: Communication without words. I stood there for what felt like hours, watching without looking, perceiving without seeing. My understanding of the situation began to shift. This was not random, not accidental, not environmental interference. This was intentional, deliberate. Something was present, something was aware, something was communicating. The certainty arrived without language, without voice, without any sensory input I could identify. Just sudden, absolute knowledge. Not fear, not curiosity, not wonder, just understanding. The way you know someone is watching you before you see them. The way you sense mood in a room before anyone speaks. Direct perception, bypassing conscious thought. I was being assessed, evaluated, studied. Not with hostility, not with threat, with something closer to clinical interest. I was a subject of observation, a data point, a specimen displaying unexpected behaviour by returning repeatedly to this location. The communication was not bidirectional. I could not send, only receive. Ideas arrived fully formed. Not as words or images, as comprehension, instant, complete. Understanding of complex concepts. No translation required, no interpretation needed. Direct transfer of meaning. I understood that this presence had been here long before me, would remain long after. That sensor 12 was not malfunctioning. It was detecting something real, something that registered on instruments designed to measure environmental conditions. The offset was accurate. The environment had changed, just not in ways the equipment was designed to recognize. I understood that my previous visits had been noted, that my return had been anticipated, that my willingness to experience rather than flee had marked me as different from other maintenance workers who had been here before. Most people ran. Most people convinced themselves they had seen nothing. Most people never came back. I understood that what I was experiencing was permitted, not forced, not inflicted, allowed. I could leave at any time. The presence would not follow, would not pursue, would not cross boundaries. It had set for itself. My participation was voluntary. My continued observation was a choice. The certainty was overwhelming. Not through intensity, through clarity. There was no room for doubt, no space for alternative interpretation, just pure, undiluted knowing. The same way you know your own name, the same way you know which direction is up. Foundational reality that requires no proof because it exists prior to questioning. I stood there receiving this wordless communication until it stopped. The flow of understanding simply ended, like a faucet turning off. The connection severed cleanly. I was alone again in my own thoughts, my own uncertainty, my own desperate need to make sense of impossible experience. The illumination remained. The shape remained visible in peripheral view. But the communication had concluded. Whatever assessment was being conducted had reached a natural pause. I was dismissed, not rudely, not abruptly, simply released from observation. I walked back to the building. I did not run, did not rush, just walked at normal pace. The presence did not follow, did not react. I crossed the threshold, and the illumination vanished as before. I was back in the normal world of electric lights and humming machinery. Chapter 8. The Rule That Cannot Be Broken. I spent the next hour documenting everything I could. Not in the official report, in a personal file on my phone. Details, observations, attempts to capture the experience in language. The writing was inadequate. Words could not convey the directness of that communication. But I tried anyway. I needed some record, some proof to myself that this had happened. I checked the sensor logs. Sensor 12 still showed the offset, still perfectly consistent. 3.7 degrees, I ran calibration. The sensor adjusted normally. The offset disappeared. 5 minutes later, it returned. The pattern continued. Function, drift, correction, drift. As if something was persistently influencing the readings despite all attempts at calibration. I shut down the terminal and went back outside. I needed to test something. I walked to the property line. The monitoring station sat on leased land, a rectangle of approximately 2 acres surrounded by fence. The fence was old, minimal, just marking boundaries, not designed for security. 3 strands of wire on metal posts. I stopped at the fence line. The illumination extended to this boundary, stopped precisely at the property edge, did not cross onto the neighbouring land. I walked along the fence. The light maintained that exact border, as if the property line was a physical barrier rather than a legal abstraction. I circled the entire perimeter, same pattern everywhere. The illumination respected the boundary completely, perfectly, without deviation. Whatever was present understood property lines, understood human designations of space, chose to honour them. I returned to the building and tested another hypothesis. I propped the door open, stood just outside the threshold. The illumination was present, the shape visible peripherally. I stepped inside, everything vanished. I stepped out, everything returned. I repeated this several times. The transition was instant, absolute. The building interior was completely protected, separate, isolated. Something about enclosed spaces created a barrier this presence would not cross. It remained outside, in open air, in spaces defined by boundaries. It acknowledged, but did not touch. It followed rules, invisible rules, rules I did not understand, but could observe in their effects. I walked to my truck. The presence did not approach the vehicle, did not come near. I opened the door, sat in the driver's seat with my feet still on the ground. The illumination persisted. I pulled my feet inside and closed the door. It vanished. The truck was an enclosed space, protected, forbidden. These rules were absolute, right? Not suggestions, not preferences. Boundaries the presence could not or would not cross. I was safe in the building, safe in my vehicle, safe anywhere enclosed. Vulnerable only in open space, only on designated property, only when I chose to be. This realization was both comforting and disturbing. Comforting because it meant I had control. I could always retreat, always escape. Disturbing because it implied intention, purpose, intelligence capable of understanding and respecting human concepts like property and shelter. This was not natural phenomenon. This was something that thought, something that chose, something that operated according to logic I could observe but not comprehend. Chapter 9. The report that goes nowhere. I completed my inspection the following morning, returned at 0600 after sleeping in my truck. Daylight inspection showed nothing unusual. I photographed everything, documented thoroughly, filed a comprehensive report, sensor 12 installation intact, no physical damage, no environmental stress, interference cause unknown, recommended continued monitoring. The response came 3 days later. Email from regional management, polite, professional, dismissive. They had reviewed my report, consulted with technical specialists, determined the interference was most likely atmospheric distortion. Temperature inversion creating localized effects, not uncommon in agricultural areas, not cause for concern. They appreciated my thorough documentation. The email continued. Due to budget constraints and facility optimization, the calibration window for this site was being reduced. Future maintenance would occur quarterly instead of monthly. Sensor 12 would be monitored remotely. If anomalies persisted, they would schedule automated replacement during the next major upgrade cycle. No further manual intervention required. I read between the lines. They were removing this site from regular rotation, minimizing contact, avoiding the problem rather than solving it. Someone had made a decision, easier to ignore than investigate, cheaper to work around than confront. I checked the maintenance schedule. I was removed from this location entirely, reassigned to facilities closer to town, sites with more predictable conditions, more conventional challenges. They were protecting me, or protecting themselves. Hard to say which. I wanted to argue, wanted to insist this required serious investigation. But what could I say? That I had seen unexplainable light, felt subsonic vibration, experienced wordless communication with invisible presence, that sensors detected something real but unmeasurable. I would sound unstable, unreliable, possibly dangerous to employ in isolated locations. I accepted the reassignment without comment, confirmed the schedule change, thanked management for their consideration, professional courtesy maintained, career protected, truth buried. Chapter 10. Others have seen it too. I tried to forget about it, tried to focus on normal work, normal sites, normal sensors that malfunctioned for normal reasons, but the memory persisted. The certainty of that communication, the absolute knowing that I had experienced something real, something significant, something that refused to be dismissed as imagination or atmospheric distortion. 3 months later, I was having coffee with another technician, Marcus. He worked the same circuit I did. Different shift, different schedule. We crossed paths occasionally, talked shop, compared notes about problematic sites and difficult equipment. We were discussing a particularly frustrating sensor array when he mentioned the water monitoring station. Said he had been there once, hated it, never wanted to go back. Something about the place felt wrong, made him uncomfortable. He had rushed through the calibration and left early. Filed a report recommending the site be reassigned. I asked carefully what he meant by wrong. He struggled to explain. Said the light looked weird, that time felt slippery, that he kept feeling, watched. He laughed when he said it, embarrassed, admitting to irrational discomfort. I told him I had felt the same thing. His relief was visible. Validation